video, we'll be solving question 3 of the past question NECO examination 2021. So this is further mathematics paper 2 part A. And the question says if alpha and beta are the roots of the equation 3x squared minus 2x minus 1 equal to 0. Find the equation whose roots are alpha cubed and beta cubed. And this question A is on quadratic equation, sum of roots and product of roots. While the second question 3B, construct the truth table for P or negation of Q. So, and the solution goes this way. Solution given the equation, we are given this equation 3x squared minus 2x minus 1 equal to 0. And we know that if we compare this with the general equation of a circle, we compare with this. We compare with the general equation as ax squared plus bx plus c equal to 0. Then that means my a, this implies that a will be equal to 3 and b will be equal to minus 2, while c will be equal to minus 1. So we have to keep these values. We have to keep them. Now, the roots given from the question, roots are alpha and beta. So the roots are alpha and beta. We have to take the sum of roots, which is alpha plus beta. Then we have a standard formula for alpha plus beta, which is minus b all over a. So we apply this, we come to the value of b and substitute. That's minus 2 all over a, which is 3. So that will give me 2 over 3. That's the value of alpha plus beta. Then the product of root, which is alpha beta, will be c all over a. Then we substitute that. So we look for the value of c from the top. So c is minus 1, negative 1. That's negative 1 all over 3. So we have to keep these values. Now, from here, we now look at the new roots given. The new roots given are alpha cube and beta cube. So new roots, which we want to find their own quadratic equation. New roots are alpha cube and beta cube. So we still have to take the sum of these two roots also. Sum of the two roots, which is alpha cube plus beta cube. This will be given us. Now we have a standard formula for alpha cube plus beta cube, which is derived. So there's no time in deriving that. We are just going to substitute it. Alpha plus beta bracket alpha plus beta squared minus 3 alpha beta. So a mathematics student should keep this in his head. So this is the formula we're applying for that. So we now substitute this. Now we'll come back to this. We have our alpha plus beta here. We put it in the formula. That's 2 over 3 brackets. Open another bracket for alpha plus beta squared, which is 2 over 3. Same thing. Just create minus 3 brackets. Alpha beta from here is minus 1 over 3. Substitute minus 1 over 3. So we have to simplify what is inside the bracket and get our answer for alpha cube plus beta cube. Now, to simplify this, we have 2 over 3 times brackets alpha square plus beta square. That will give me 4 over 9. Minus times minus will give me plus, and 3 can cancel today. So the remaining number will be 1 here. So after this, we deal with the bracket first. We combine the fractions together. That's 2 over 3 times. So now, in order to add 4 over 9 plus 1, we can just simply say 9 times 1 plus 4. That will give us 9 times 1, 9 plus 4. That's 13 over 9. So the next thing is to multiply. So nothing, so we have to multiply. That's 2 times 13, that will give me 26. All over 3 times 9, that's 27. So, therefore, alpha cube plus beta cube will give me 26 all over 27. That's alpha, that's sum of the new roots. Now, product of the new root, which will be alpha cube beta cube, this can also be written as alpha beta all cube. So we have to substitute. What is alpha beta from here? That's minus 1 over 3 all cube. So we have to break this down. Alpha cube, now minus 1 cube. Cube of a negative number. If this power is odd, we keep getting a negative number. And if the power is even, we'll be getting positive number. Now, this power is odd this time around. So minus 1 raised to power 3 will give me minus 1. And 3 raised to power 3 will give me 27. So this is alpha cube plus beta cube. Alpha cube, alpha cube beta cube will give me minus 1 all over 27. Now, we have a formula. The required equation can be gotten by using this formula. Required equation. Required equation can be gotten by using this formula. It is x squared minus sum of roots x plus product of roots. So we equate it to 0. Now, this is what we are substituting. We have sum of roots and product of roots above. We put it there, put them there, x squared minus sum of roots. I'll come to this. This is my sum of roots. That's 22, 26 over 27 x plus product of roots. Product of roots. Where's the product of root? That's alpha cube beta cube. That's minus 1 all over 27 equal to 0. That's how it goes. Now the next thing is to simplify this last equation and get my final answer. That's x squared minus 26 over 27x minus 1 over 27 equal to 0. Now, we cannot leave our answer like this. We still have to clear the fraction by multiplying through by 27. Let's multiply through by 27. So, we multiply through by 27 to have 27 x squared minus 26x minus 1 equal to 0, because 27 equals to 27 when we multiply this by 27, and when we multiply this by 27, 27 equals to 27, and this is the end of question 3a, which is the required equation. So thank you, and follow me to the next to question 3b. Question 3b, we are asked to construct the truth table for P or negation of Q. So what I will do is I'll draw my table. Let's draw the table. I'll draw my table. Then I will divide it into columns. So this column will be for statement P, and this column will be for statement Q. So I still need to draw another column. So I have to draw another. This column should be for statement negation of Q, because if we look at the question, we are asked to construct a table for P or negation of Q, not P or Q. So that means the last part of the table will be for P or negation of Q. So this is what we need. Now, the standard from logic, this question is on logic. It is standard from logic that we should keep true, true, false, false. So these are the truth value of Assuming P is true here and it's also true, false, and false. So that means standard also to have true, false, true, false for Q. So we now operate, before we start operating, we still have to find the negative of Q. The negation of Q, the meaning of that is that the opposite. So if Q is true here, its negation will be false. So standard. And if Q is false, its negation will be true. If Q is true, the negation will be false. And if Q is false, the negation will be true. So here in this column we have false, true. Now let's operate this. We are going to operate this column and this column together. This column and this column. So I will operate T or F together. And one thing about this logical connecting, take note of this logical connecting. One thing about it is that the result is going to be true if at least one of the two statements is true, and false if none of the two statements is true. So now this time around, if we operate true and false together, at least one of them is true, then the result will be true. And also true, since both of them are true, then the result will be true. And here, false, none of them is true, then the result will be false. Now, false, true, false or true, false operated on true. So since one of them, at least one is true, then the result will be true. And our final column here is true, false, true. So this is the end of question 3b. So that means we are done with everything about question 3. Follow me to the next question in the next video.